Hello everybody and welcome back to another great episode of PASCO Live. I'm JP and Dan, do you know what the P stands for this week?
Plexiglass?
It could stand for plexiglass, just one way that we keep ourselves safe here. And of course, if you're a chemist, you know that this is polymethyl methacrylate.
Of course.
All right, so different ways to communicate, but it's not so much about the plexiglass. It's more about this week is passion. Passion. Because I'm very passionate, and I know Dan is very passionate too, about bringing things to you and to your students for distance learning and being able to communicate to your students with distance learning in ways that make it easy for your students to learn. We have somebody that even wrote in this week from Claremont McKenna, and so we're reaching out in a nice hello to Thomas Dersham, who's sharing this with his folks back home to take a look at how we might be able to use software appropriately so that we can do things in our classroom and we can share them with our students. And so I guess the big question is, and we've been doing a lot with distance learning, wouldn't it be great if you could just do things here in the laboratory and then let your students do their thing at home and be able to communicate easily? Wouldn't that be great, Dan?
Well, in an ideal world, hopefully they'd collect their own, but that's not where we live now.
That's right. And so we want to be able to collect and share, and we're going to show you how to do that because we're doing it, and we're doing it live. Let me introduce myself. I'm Dr. J.P. Keener. I'm the former director of STEM for the State Department of Education, and with me on the other side of the plexiglass here is Mr. Dan Burns. And Mr. Dan Burns is a 30-year educator. He's a STEM specialist and recently an AAPT recognized scholar. So welcome, Dan. It's nice to have you here.
Great to be here.
And you should also know that working to answer your questions live, as we are live, we've got Brett Sackett and Boomer. Excellent. Thank you. We see Boomer is getting ready to answer your questions. We're thrilled about having him. And of course, if he can't answer them, I think Brett's going to be able to answer them. And if you have any questions for Dan and I, just write on in. This is live. Brett's collecting your questions. He's answering what he can. If not, he'll throw them over to us. But the everything that we're going to be talking about today will be recorded. And any of the things that we've talked about over the past several weeks, where we're trying to show you great resources for distance learning, is available to you. All you have to go is to our PASCO Live events page on our website and take a look at what's there. You will now find 6 recorded episodes of resources to help you with distance learning. But this week specifically, we're going to be looking at 2 different types of software, SPARKvue and Capstone. And so, Dan, you and I kind of been talking back and forth a little bit about like what are the benefits of like having one over the other. In my chemistry classroom, my biology classroom, SPARKvue's been very handy, and I'd be prepared to say that for 90% of the stuff you do in K-12, you could probably get away with just using SPARKvue. What do you think?
But if you teach physics, you'd want to have Capstone, I think.
And I think you're probably right about that. And Dan's going to show you why, and certainly at the university level, and I know, Dan, you agree that the Capstone is probably the only way to go.
Right, I would go with Capstone.
I would go Capstone too. And so we're going to show you why. Now, what we're going to do today is quick, it's fast-paced, it's a lot of information. Don't panic, we've got lots of video support for any of the things that you want to spend time, but we just want to show you the ease with which we're going to do things here live, share it with you, just as though we were doing distance learning. We're going to model it, we're going to share it, we're going to show you exactly how that works. So, you kind of ready to do that, Dan?
You bet.
So what I want to talk about then is recognizing our software. And before Dan and I get started with like specifics in the software, I just want to say these couple things. First of all of our software connects to all of our things. There's only, if you've got SPARKvue, it connects to everything. You've got Capstone, it connects to everything. The old stuff, the new stuff, the stuff we make in the future, all connects to that one software, whether it be SPARKvue or Capstone. And in both cases, as you can see here from my computer screen, it will collect and display data here in a variety of different formats with robust analytical tools. Here you can see I've got a table and I've got a graph. And so these are common across both SPARKvue and Capstone. The other thing that's important for you to know, because a lot of folks write in and say, hey, can I just export that data to Excel? And absolutely. If you don't want to work within our software, collect your data and export. in both Capstone and SPARKvue, you can export this stuff into Excel and work in Excel. No problem with that. And you should also be excited to know, as we've been talking about over the past couple of weeks, computational thinking has been integrated directly into everything that we do. So if you're thinking about doing computational thinking, you can do it in SPARKvue and you can do it in Capstone, both. So now what we're going to do is show you some specifics about what you can do with our software and different things. And so I'm going to start off, Dan, if that's okay with you.
Yeah, what do you got there?
Well, I've got a pressure sensor, and I've got the pressure sensor is hooked up to a syringe, and I'm going to push this syringe and I'm going to change the volume, as you can see here, going from 60 to 50 to 40 to 30, a pretty good push on that. And I'm going to be taking a look at the relationship of pressure and volume. Whose law is that?
Boyle?
That's correct. That's Boyle's law, and we're going to demonstrate that. So if we can take a look at my computer screen here, I am going to demonstrate that exact process here. So I am now here. I've already connected my pressure sensor. You see my pressure sensor is connected here. And you see I've got three different options for looking at it, but Boyle's law has already been designed. So I'm putting in those numbers, the 60, putting in 50, these are the numbers on the syringe, 40 and 30, and okay, I think that's enough. And so I'm already got my graph set up for pressure versus time, and I can start doing manual sampling. Let me push in that syringe, here we're at 50, pushing it in some more at 40, push it in again at 30, and I could do different volumes, but this is pretty good just to show you at home what's going on. Look at this graph. Look at this great graph. Let me stick a curve on here for you so you can see it. And isn't this what you'd expect to see with pressure versus volume? A very nice inverse relationship that's here. But we don't just stop there. We know it's an inverse relationship, so I can go in, or we already have for this one, and do a calculated data. Here it's an inverse pressure, and so I'm going to use that inverse pressure. So I'm going to go back to my graph. Let me change pressure, and I'm going to change it to inverse pressure. And now look what you see, Dan. Look how beautiful this is. Watch this. Nice line, yeah? And look at that. What's the R value? 1. This is so beautiful, I'm going to label it. I'm going to call this the inverse pressure versus volume. And I'm going to save that. And for our students at home, if your students are making this at home, they can save that. Watch this. I'm going to take a snapshot. And now I've got that. I'm going to export that snapshot, because with that exported, let me just save this here on my desktop. Let me close out of the software here so you can see my desktop. There it is. I exported that journal. Here it is on my journal. When I open that up, I can see the different things I just exported. That's got the little picture there. So if I'm doing something in PowerPoint, I'm doing a PowerPoint presentation, I'm going to drag that picture in, and boom. There I got Boyle's law. Or maybe I'm submitting a lab report and I want my professor to see the lab report. Here I've got a lab report I'm working on. I'm going to drag that picture in to Microsoft Word, and there I have it. So I have the opportunity now to not just do the lab, but I can save aspects of the lab. I can integrate those aspects of the lab in, and I'm able to put those all together in a nice presentation so that I can show that. What do you think, Dan? How's that look?
That's great. Can SPARKvue also be used to display things?
Oh, absolutely. You can display both in SPARKvue, but then you're able to put it in different formats also. And so I think we're able to do that. And that was like Boyle's law in chemistry. I think probably what I'd like to do is something, and please, I don't want to overstep boundaries here, but do you mind if I do something with physics?
Go ahead.
Okay. I'm going to. So this is our smart cart. If you've never seen our smart cart, you really have to look online and see that. And what I'm going to do with this smart cart, it's got a force sensor on the end. And with this smart cart, I'm going to pull this force sensor on the back, and I'm going to pull this cart back and forth because I want to take a look at the relationship of force and acceleration. That's one of Newton's laws, isn't it, Dan?
It's number 2.
Number 2. So we're going to be taking a look at Newton's number 2, the second law of motion, and I'm just going to pull that back and forth, and as I'm doing that, I'm going to be collecting the data. So let me come back over to my computer screen here, and let me get hooked up with my cart, and here we go. So I've got my cart hooked up. You see my cart is hooked up here on the left, and I'm looking at number 2, which is the relationship of force and acceleration. And I'm going to look at the graph, and you can see here as I pull this cart back and forth, There we go. You can see that I'm collecting some live data directly for two different graphs, force and acceleration. And your question might be, well, what's the relationship between force and acceleration? So let me go to another graph here. And I'm going to change the axes as I can do in SPARKvue. On the y-axis, I'm going to put force. And on the x-axis, I want to take a look at that acceleration. Put them both on the same graph, and I got a very interesting graph there, don't I? And if I draw a line on here and get the slope, what do you think the slope's going to represent, Dan?
It would be the mass of the cart.
That's right. This is the mass of the cart. And you can see here, 0.249. Let me see if I can do that a little bit better. I'm going to try that one more time. We've got some pretty good data that time. Let's draw a line on that and see how that looks. Hey, 0.250. That's a pretty good number, isn't it? And so what's the mass of the cart? It's about 250 grams. So that worked out well. Now watch what I'm doing here. Folks at home want to know, like, what do I do with this? How do my students save this and see it? Well, if I'm the professor, I'm going to save this just like I'm doing now. I'm going to save it. I've named it. I'm going to close out of SPARKvue altogether. Let me shut out altogether. Now all you see is my desktop. Here's the lab I just saved, right here. When I send this to my students, they're going to open it and they're going to see all the data. Whatever data you wanted your students to see, they get to see. Let me just look at run number 2 here. Here's that data. Remember, we went and looked more at a specific graph of the force and the acceleration, and here it is. That data that I saved is here, both as the two different graphs, or the graph that has just the data that we just collected, and of course the other run is here also. I can go back and take a look at run 1. Remember the initial one we had, and it's available. So you collect the data, you save the data, you send the data to your students, and boom, there you have it, and you're able to give it directly to your students. So that's a pretty nice capability, wouldn't you think, Dan?
I think real useful for these days.
Oh, I think it's real useful too. And so what I've just done here is a great example of how I can collect the data, save the data, and share that data. But I'm going to take it one step further with you. Well, I've still got the smart cart and I've got it hooked up. I want to show you something really nice. If you want to put together a complete lab for your students to do either in class or at home, this works both in great places, you can build what's called a Spark Lab. We've got some built for you, but you can build your own. Let me show you how. Let's go back to my computer screen here. So my smart card is hooked up, and look, I'm going to open these PASCO experiments over here, and I've already got one on building better bumpers. And so this is what they look like. You can do one that looks just like this. You can make your own. We have some built for you as examples, but you can make your own. You'll notice that as I click through this, you have opportunities for your students to put in text. It talks about the materials. It shows the setup of the lab. And look, I can collect this data live, just as I'm doing here. Collect that data, and then I can save this as a workbook and save it, and my students can have that and do that. Now, you might want to make your own pages. You see there's a couple different pages, a couple different formats. I'm going to add my brand new page all by myself here. I'm going to customize this lab. I'm going to put a picture over here on the left, and let me put some numbers on the right. Let me go to my pictures, and let me get Boomer back in the picture there. Hi, Boomer. Put you in here, get the numbers over here on the right. Let's put in the force, and now I've got a new page. Maybe I want to add another page, maybe something graphical. We didn't see a graph yet, so I put a graph in on the next page. And you see what I'm doing, Dan? I'm building a lab that I can save as a Spark file, and I can send to my students, and they can just click through the pages, and they can see the data, and they can enter the data, and it makes it very easy for us to build these things, to share these things, and to make it possible for me to do almost anything with my students by building it here and then sending it home. And that's really a great thing. So these are called Spark Labs, very similar in Capstone. You can make Capstone files, can't you?
Capstone does the same thing, yes.
Right. And so in both cases, we're able to share things back and forth. So Dan, I think what we want to do while I'm talking about the smart cart is let's get you set up, and let's talk a little bit about what Capstone can do at a higher level if you want to take this to the next step. Dan, what do you have here, and what do you think you're going to be able to do with it?
Well, physics teachers like to have their students create models using data that they collect, and Capstone and the smart cart makes the data collection a snap, I've got an incline here. And so the first experiment is just going to be simple. I'm going to release the cart from rest and let it go down the track, and we're going to collect position time data. So we got Capstone started there.
Okay, let's go to your computer screen. We've got it all connected up, and we are ready now to look at your computer screen.
So we got a position time graph.
Okay, go ahead.
And we hit record. And there we go.
Hey,
oh,
nice.
I should have caught it.
Nice.
And so we get a nice parabola, but maybe students aren't aware of that, so they can try things. I tried a linear fit. That clearly shows it's not a linear fit. But PASCO Capstone has this quick calc feature. So they can quickly try other things to try and linearize the data. And here, square root of position gave me a linear graph. Well, if that's true, I could also try time squared and also get a linear graph. And the slope would be half the acceleration, and they could figure that out by looking at the slope of the velocity graph. Well, let's do something a little more challenging. I set the stop condition to 0.8 meters so I don't get the crash at the end. And the start condition is 0.2 meters. And so now the data collection will start when the cart is already moving. And so if the students are trying to do the same thing that worked when we started it from rest, they're going to find out, hey, that's not going to work, but the tools in Capstone will make them successful in trying to figure this out. So it's definitely not a linear fit, and we could try a quick calc on the y-axis or the x-axis, and they find out, oh, time squared, oh, that doesn't work at all. But we have also other equation fits that we can try. And so let's try a quadratic because we have that linear time term now. And so that fits perfectly. The A term would be half the acceleration, the B term, the initial velocity, and the C, the initial position. And they would be able to figure all that out on their own.
And really, we got some really good data from that. And the nice thing is that you were able to share that. And you did a lot of the analysis here yourself for our folks back at home. But I would guess that you'd want your students to be doing a lot of that analysis.
And so they learn these tools. Once they learn them, they can discover things for themselves rather than having to memorize things out of a book.
And in some cases, you do things that you would be doing as a demonstration in the classroom anyway, right?
You could.
And then some of these tools would be great for demonstrations, but you still want your kids to learn what's going on at home.
Because with the smart cart, the data that we just showed when I first started teaching, that would have taken 30 minutes before students saw that position time graph. Now they just get it in a few seconds, so they have more time to come up with their own investigations and to do analysis.
So what can we do with this then? This is a nice device. We can do all kinds of things with it too, I would gather.
So I have our wireless acceleration altimeter connected to our rotating platform, and the wireless sensor also has a gyro in it. So first we're going to use it to measure the angular speed. So I'm just going to give it a counterclockwise push, so it'll be positive, and then
let's take a look at your computer screen and see what we get on your screen, okay?
And so as it slows down, you can see it's slowing down at a linear rate, pretty linear, and so that's angular velocity as a function of time. So they might want to see what the slope signifies and what the area under the curve signifies. So they get the slope, oh, something's wrong there. Oh, it's giving me the slope of all the data. Well, we just use the selection tool to select the part that we're interested in. And so that slope they would discover is the angular acceleration, negative 0.9. Then we could get the area under the curve, and we know that is the angular displacement, but students could figure that out for themselves. So they could create some calculations. Here I've created some to start with. I created the integral of the angular velocity. Well, that's going to be the angular displacement, and then the derivative would be the angular acceleration. And so now they can generate a graph of the angular position, and you can see the final matches real closely to the area under the curve. So they would make that connection, also looking at the units. Angular acceleration as well, they can display that. and it comes out real close to negative 0.9, a little jumpy just because we didn't level the platform real well. But there's also a smoothing function which can take some of that out.
Look at that. Beautiful.
Now that's rotational kinematics, but we also had an accelerometer in the sensor as it was spinning. And so let's look at another graph. Oh, here's we should show you the slope tool. And so if I measure the slope of the angular position and then use the multi-coordinate tool, I can find out that the slope is the angular velocity at that point.
Wow, very nicely done. Nice to see those line up.
So now back to the acceleration, I have an acceleration versus angular velocity graph here. And so while it was spinning, we also collected that data and we get a nice parabola. By now the students know, hey, I'm going to try quick calc and see if I can linearize that, get a nice straight line. Now they also should be able to figure out what's the significance of the slope. And so very quickly they have the slope, it's 0.24 and it's in meters, and that is the radius that the sensor was at. And so they can figure out the centripetal acceleration is the angular speed squared times the radius without having to read it in a book or memorize it. They figured it out for themselves.
So again, we're seeing the students do the type of level of analysis that we would want our students to be doing at home. And I got to say, Dan, when I'm looking at this, I understand why you're saying, like, this is what physics needs. This is what physics would be needing to do at a very high level. And we showed a little bit about, like, kinematics. We showed with the smart cart and some rotational things. But oftentimes we're teaching a little bit about electricity, too. And in one of our previous Facebook Lives, PASCO Lives, you demonstrated how we could use things like circuits and teach a little bit about physics, but I think you can show me a little bit more, can't you?
So I have a modular circuit, RC circuit. I've got 2 batteries, a capacitor, and a resistor, and then a switch that I can use to, when I switch it over here, it'll charge the capacitor, and then over here it'll discharge it. And notice how modular circuits under the camera looks just like the circuit diagram in the textbook. So you could collect this data, show the students the video, give them the data file, and then they could do all this analysis that we're going to quickly run through. And so let's...
and I see also on here, Dan, you're using the wireless voltage sensor to collect some data, and it's got the wireless current module in there too.
So we got current and voltage.
Excellent. All right. So let's get this hooked up. Let's take a look at your computer screen.
And this is a current time graph. And it charges really fast and discharges really fast. So we're running at 500 hertz data collection. And then we can play it back using the data playback feature. You can have it go slower, you can rewind it, you can pause it. And so things that happen really fast you can study more carefully. Well, just to highlight all the analysis tools, I'm going to measure the capacitance of the capacitor 4 different ways. So first I'm going to get the area under the current time graph, and so that would have the units of coulombs, so that's the charge on the capacitor, and that equals 1/2 the capacitance times the voltage squared, where the voltage would be the voltage of the 2 batteries. Now we have a voltage time graph, and we're going to again charge the capacitor and then discharge it, but now you see the voltage go up and reach a constant value and then go back down. So let's zoom in on the charging part. And so you can just scroll the axes, you can use the selection tool, lots of different ways to arrange the graph the way you want it. But you can see we get a nice curve here. And one way to measure the capacitance is to find the half-life, which would be when it's at half the maximum voltage. And so in this case, 0.024 seconds, that equals the natural log of 2 times the resistance times the capacitance. And so that's the second way to get the capacitance. We could also do a curve fit. Now that suggests inverse exponential, and so I selected that, and then we again have to just select the data that we're interested in, and we get a nice curve fit where the B term is the time constant, which is 1 over the resistance times the capacitance. So again, knowing the resistance, they could calculate the capacitance. And I said 4 ways, and so the 4th way, we have the discharge. And so we can select that as well and do a curve fit, but the inverse exponential isn't going to work. We need an exponential that decays down to 0, and so that's one of the many choices there in the capstone curve fitting list. And once again, we get the time constant, and it's pretty much the same as what we got with the charging. So you got 4 different ways in this lab, lots of analysis for students to do with an RC circuit.
So I'm really just overall impressed, and hopefully our folks at home are saying, oh, I might not fully understand what Dan's talking about, or maybe that's just me, but I think our folks at home are saying, I might be able to demonstrate almost anything with these softwares, and we're modeling it here. We're showing it to you, we're collecting the data, we're showing you the data, we're sharing that file with our students at home. Our students are doing the analysis, a lot of the analysis that Dan just did, and then our students are sharing that back to us, either maybe a PowerPoint and a Word document. They can put it back in the same type of file and send it back, or discuss it with us, and that's what we want our students to do. Critical thinking skills enhanced by this type of software that we're able to share things back and forth. And Dan, I got a feeling you're probably not even done yet.
I could just keep going on and on. What about video analysis?
Well, let's look at your computer screen here for a second. Okay.
Falcon 9 first stage booster re-landing. We
Nice.
can figure out that.
We could do some video analysis. I bet there's a whole bunch more too. And honestly, Dan, for the sake of time, we're not going to, yeah, exactly. We're not going to get into all of the things that you can do with Capstone because it would take forever.
We
The
should
good
do
thing is,
another one, though.
we should do another one
yeah.
just on video analysis. I agree, and if you folks want it, just write in, let Brett know you'd like to see some video analysis. We do have, in our PASCO video library, we do have some files that are ready for you that can already do video analysis. And we've got a whole bunch of other stuff that we're talking about here in our distance learning library. All of the stuff that we're talking about today with PASCO Software and the different labs that are available are on the Distance Learning for Teachers website. Just go to pasco.com and look for Distance Learning for Teachers, and you're going to find all of this information that we've been sharing with you today. And I want to share something else with you here because I've got a nice little letter from Jill Serling who said, taught me a brand new word, FOMO. You know what FOMO is, Dan?
No, I have no idea.
Yeah, it's neither did I. But Jill taught me that this is fear of missing out. The fear of missing out because we always have such great deals in every one of these PASCO Live opportunities. But here's the crazy thing about all this software, Dan. Yeah, SPARKvue is free. Now, it's true. If you're downloading on Windows or on Mac, you can get a site license. We can work out a deal on that. Capstone does have a price tag associated to it, but it's a very small price tag. And as a special today, if you let our folks know that you've been watching Dan and JP, we've got a special deal for you just on these site licenses for this. And if you just want to try it out, and here's the really crazy thing, you can just download it today from the pasco.com website, and it's available for...
typo? That can't be 180 days.
It's 180 days. Yeah, that's 6 months. That's unheard of.
Wow.
Right. So if you're teaching and you're going by the semester, you need your students to be using this at home, you don't want to send them the link, that's fine. Let them download the trial version and they can use it for the entire semester. They can use it for 6 months. And I would say that that's pretty good. But if you still want that deal, you want something to download, you want that site license, here's where you can go. Just reach out to Isaac Martin. His contact information is right here. Isaac Martin is our sales director, and tell him that Dan and JP sent you. Dan and JP sent you, and he's ready to give you a deal on this Capstone site license for your entire campus for as long as you want to use it. Once you bought it, it's yours. Connect with anything, share it, use it, let your students use it, and do the same stuff that Dan and I were doing with you here. And if you're one of our international partners, don't panic. Capstone and SPARKvue are international tools, and you can reach out to your international partner, our international partner, and contact them and get this same software, and the same opportunities exist for them. And so that's really great stuff. We did a really quick overview, Dan, but they can find a whole bunch more in our video library. They can find a whole bunch more, and if they want training on this, do we do webinars on this?
Tons of them.
Right. And so if you want to learn about any of this, just go to our webinar page under training, and we do free webinars that you and your students can sit in on and learn about this so that they can use this software, and there is no charge for that. And so that's what we have for you this week, an opportunity with a whole bunch of free stuff so you can do distance learning with your students. Next week, Dan, what will you be doing next week?
Maybe taking the day off.
You might be, because you won't be joining us next week, but we will be doing something fun without you. So you're going to want to tune in. Next week, ladies and gentlemen, we're going to be breaking things. And of course, it's science class, so not just breaking things, but we're going to be breaking things and measuring that breakage. So join us next week for PASCO Live, where we break things and measure it. That's going to be fun. But for this week, we hope that you saw a little bit about what you could do with SPARKvue and a little bit what you could do with Capstone. I know that Dan did a great job, so thank you, Dan, for joining us today. And for all of us here at PASCO Laboratories, we want to wish you the best of luck and good day.